This is one of my favorite talk, like where I want to make sure that I was always curious, like, how the big companies are designing the system. And what I'm really proponent is see other people, how they are successful in implementing the similar solutions we need. That's what I'm really very much interested in understanding. So we'll be looking at that more as part of the cloud scalability and system design. Now, as part of this, like one other thing to look at is what are we going to talk about? We're going to talk about system design. We're going to start with how the calculations is done. When we say calculation is done, you have been given a problem. This is what happens. Any architect here or any developer here, first thing what happens is you have been given a problem, solve it. That's what you're saying. And we're trying to figure out, what do I do? Okay, build the screen. Yeah, that's what happened. Like, I want to do this. Really, you don't know the whole puzzle, how that whole puzzle is built. And that is the real cause of the problems. So what we need to build is a beautiful architecture, like, butterflies. We want to build systems which are interacting and, with scalability in mind, all the agility, security is also in mind, and the performance is there when we are building the systems. So in order to do that, what we need to do, we need to put a lens. So this lens I'm trying to put is, see this here. The problem is that when we try to first see a problem, it is not clear. That's what happens. When we look at any problem, it's not clear. When we start to put the lens, this lens is coming in, and this lens is the questions to ask. So what I'm going to tell you is what questions to ask to be successful. That's it, simple as that. Once you know, you can figure it out how to solve a particular problem. Yeah? So that's where the system design really comes in. So when we say system design, if you look at this here, if I start from the gateway, from the top here, what's really happening? We are connecting to the portal. So this portal is now connected to the sales. So whenever you start any product journey, it starts from what? Campaign. You're starting a campaign, but that campaign is starting, what do? You generate leads out of it. Hey, I have a promotion going on. Mother's Day is coming, Father's Day is coming, or Diwali is coming. There is a promotion going on. Based on that promotion, then you attract the person to get an order. Once the order is generated, then what you're doing is you are talking to the billing, get the money first, yes, dollar amount, yeah? And then you're having a delivery, somebody delivering to our step door, and we are fixing all these. This is a very complicated system. And we all have it. We are playing some part or the other. We are creating a SaaS offering exactly to solve this problem. So in order to do that, we also have business intelligence to solve some of the complicated routines. Hey, is this a fraud or not? That we have to detect. We have to make sure the security is in place for all these things. And then after this is the corporate entity. Tell me I if that's what you got. Just say I, yes? Just raise your hands, yeah? This is your company. This is exactly your company looks like. So what happens is when you're building these companies in the public cloud or private cloud, even if you're using the microservices, what you're trying to do is you're actually fundamentally looking at understanding the functional requirements. Non-functional requirements, yeah? What do? We find out what the requirements are, ask the right amount of questions, understand the requirement well, and that's where Albert Einstein said, if you have 1 hour to solve a problem, do you know how many minutes you need to understand the problem? 55 minutes, I have in all my slides, you get that really well, awesome. So then we get the non-functional requirements. And these are all the agilities, and Mark Richards' talk, if you say, he's saying that this agility is more, this is less. But tell me, your product owner is going to say that, hey, I want less agility here. I want less response time here. Nobody's going to say that. So take it out of the door from your perspective. Response time, period. It has to be less than 250 millisecond response time, no matter what you design behind the scene. So this is what the misnomer comes in. Hey, I want to see which agility will work for this architecture. No. Response time, 250 millisecond response time. Or actually, I would call it differently. Microsecond is a new millisecond. What is it? Microsecond is a new millisecond. That's a different way of thinking. We'll talk about that. And the use cases and the APIs. And then without data model, you can't understand it. We need to understand the data model to do that. You need to do the capacity estimation. And then you need to design and then work on the risks at the end. So let's take a look at the requirements perspective. So empathy map is the first one. So when we say the empathizing for a given customer, I want to make sure for a given customer, let's say Uber, who's using the Uber? Who will use my service? That something has to be very clear. And then what are their pain points? And based on those pain points, when you're using your system, now you need to design the service. So that's where this comes in. Now the scalability. These are the 4 questions you need to ask for scalability. Number 1 is how many read queries per second. When I say read queries per second, that means you may say that, oh, there are 100,000 read queries per second. You need to support that, okay. And then how many data queried per second? Let's say you're just getting 1 megabyte of data. So 100,000 times 1 megabyte of data, 100 megabyte of data per second you need to support. It has to flow through your bandwidth, yeah? So there are limitations, by the way, in terms of how many web servers do you need, how many app servers you need for that purpose. How many views are making per second. And what is the traffic spike looks like. So what I normally say to people is that you find out what is your average load looks like. Whatever is your average load, let's say the average load for that particular time is 25,000 requests per second. What do you need to design for? You need to design for 5x or 10x. So 250 or 125,000 requests per second, that is what you need to design for. So that's another thing which is important. Now in terms of performance, the important measure here is the read to write data delay. When I say read to write data delay, what that really means is that when you're using the system, on the left hand side you have one system calling another system. Now when you write the data, there is always a delay to go to the other system. Even you're using NoSQL database or SQL database, does not matter. You're using event-driven development, in that case, there always will be a delay. So that's number 1 you need to understand. Number 2 is P99 latency. So what is P99 latency means? Anyone? What do you think? Huh? 99 percentile. So we are looking for 99 percentile of the whole data. So that's exactly what we are looking for. That means we are not looking for 1% because there always will be a network failure going on, which you're going to take a more amount of time. So you need to design for that. And the availability. And people always say 99.99% available. That's not possible. So you need to know what your availability looks like and design and give the SLAs accordingly. So what happens is, like this is kind of the cache, I'm talking about the cache perspective. So what happens is from the Cal1 cache perspective, so caches have become very, very cheap. That's the way I would call it. So what's really happening is, this is just a slider scale, which I'm showing here, which is saying that, hey, now with 2020, the N1 nanosecond. So, and also the caches become so cheap, you put everything in the cache. If you want to know, like, how we are using caches, and some people say only name value. Hey, I only need to do name value. That's what we put in. How many here are only using name value in the caches? Yeah. So if you want to really scale, pub sub you can do in the caches also. Publish and subscribe, it can be done in the caches also. Search you can do in the caches also. Not only the search, you can do the document, put the whole document in the cache also. Not only that, you can do fuzzy search on the document store in the cache also. So that means that's what's happening now to basically increase the speed. So that's the way we are doing it. Another thing is important is how much is your throughput? How much data you need to process per second? That is an important number you need to understand. And you need to design to minimize the cost of development. Like you should take less amount of time to design and minimize the cost of maintaining also. These are the two things if you do, cost of development is less and maintenance is less. That will help you drive your decisions. Now what happens is, this is a useful calculation. 1 million users, 100 kilobytes per day. 100 kilobytes per day, that means 100 gigabytes per day we need to calculate. So this calculation you need to know for your company, what that looks like, okay? So what that means, okay, so this is you can cheat sheet, you can call it. So a file, if you have a file, it's 100 kilobytes of a file is there. And then a web page is also 100 kilobytes. Now if you have a video, for example, Instagram. Anybody using Instagram here, you know? So that is typically around 2 megabytes of data is there. And then, you know, streaming video, 50 megabytes per second. Using these models, now what you do is maximum URL character. Don't go more than 2,000 or 1,500. But maximum is what? 2,000. You need to know the limits for this. But then you calculate per day how many people are calling. That means per second what you need to support. So why I'm talking about per second, it will be important for you in a second. So let's take a look at Shutterfly. Shutterfly is where you can upload all your photos, okay? So 100 million photos, 200 kilobytes per day. So 100 million times 12, it is coming out to be how much? 250 megabytes per second. That is the traffic which is flowing through, which is flowing through us. So let's take a look at different usages. Like, you know, Facebook has how many megabytes of data is there for the Facebook. So in order to do that, let's go to similarweb.com. So if you go to similarweb.com, and I'm going to go there now. So this is the similarweb.com where you can actually go in and find out global ranking. Google is 1, and then Facebook, Bing, and Twitter is there. Number 5 is there. Now for Google itself, there are 257 billion requests are being sent just within 3 months. See? So now you know how many users are using the system. So one of the figures what we are interested in is the monthly active users. Okay? Why that is important, anyone? Why that figure is important? Huh? For capacity planning for what? For caching the data. It's not for the database. You need to cache the active users because active users are using the system really well. So you need to know what are your monthly active users who are actually using the system, and then based on that you're going to determine, like, you know, how many pages they're visiting, what's the bounce rate looks like for you when you're calling their system. Yeah. So and then where they are making call, like United States, India, you know, India is number 2. See, top countries, India is number 2 in this chart. So a lot of people are using and there is a marketing involved also. So why the marketing is involved? Because of Instagram, from Facebook. You want to project, hey, this is what is coming in, and you're trying to build the channels based on that. Yeah, and then there are paid marketing and other marketings are there. So based on these results, now what happens? Now you know what thing is popular among different industries and what data you need to process. Based on that, we know that, you know, these are the major people who are using the system. Let's see how they are being used and design our system based on that. So let's take a look at one more example here. So SQL database. SQL database always comes in. What's the maximum size of a SQL database? Anyone? I gave some answer there. Yeah. So see this here. So you have petabytes of data, or like, you know, you have a lot of data is there, or terabyte of data is there. How do you put it in this storage? You can go MySQL, you can go 100 terabytes, no more than that. Yeah. So you need to find out what that looks like. Based on that, you have to make a decision. Now what happens is, you know, people say that, oh, I got this database, I cannot use SQL database. But you need to do ACID transactions. How can you do ACID transaction without using SQL database? Yeah, enterprise systems you're trying to build. How do you do that? How does Coke do it? Anyone? What does Coke do? What do we do in that case? That's the question we need to answer. You know, we need to divide the data. Database sharding we need to do. For example, India Coke system can be a separate database. You know, Europe can be a separate database. US can be a separate database. Now what we are doing, because we are doing database sharding, we can put it in that data. Now you can say that, yeah, US, still a lot of Coke is there, like, you know, why should they keep all the data in the SQL database? That's my next question. So why I'm talking about this is, people think that you have to put all the data there. No. You have to put only data for 3 months. Yes? And take all the other data and put it in DynamoDB or the standard database. Because you don't need it. You don't need the transaction. You don't need to be ACID transaction. How much return you can do. After some time, you don't need to do that return. Yeah? So that is what happens. You need to optimize what's happening here. So what that means, how many requests per second is coming in. So if you have 25K requests per second is coming in, that is perfectly fine. So you need to know whether this will work for you or not. Same thing is true with the Redis cache also. Redis cache is 300 gigabytes of data. Now, Twitter, for example, uses Redis and store all the timeline in that. Now, they put all the timeline for all the users in Redis cluster. How do they do that? How do they do that? That's an important thing to understand. So what's really happening is, let me talk about that for a second. So what's really happening is, this is the Twitter account. So let's just talk through this. So what's happening is, when the user is logging in to the network, so this is a user who's logging in from Twitter, yeah? It's going through the gateway, so this is the gateway looks like, and then now it's connecting from here to this service. This is calling the timeline service. And then now here I have got cluster of all the accounts, all the Redis accounts. Redis storage is there. Now why I'm having multiple of them? Because I'm having a zookeeper here. Zookeeper here who is going to orchestrating the whole thing. Now what do I need to do? I need to just put the tenant ID or CID, C1 colon, and then I can say Redis cluster R3, yeah? C5 colon R6. So this I store in my cache. Now what's happening is, now whenever any request comes in, a user logs in, I have the timeline ready to go for all the posts they are trying to read. So that is the way you get the advantage of increasing the load if you are using any of the system which you are talking from the Redis perspective. Does that make sense? So that's the way you get the benefit of increasing the scalability of that cluster. NoSQL database, on the other hand, is talking about 20K to 50K. 20K to 50K requests per second. So that means, so this is what the limitation for the NoSQL database is. Yeah? And then the web server is 5 to 10K. Let's say 10K they can process. Let's say you are having a request which is coming in, 50K requests are coming in per second. How many web servers do we need? 50K requests per second, anyone? How many web servers? 5 web servers, yeah? I would say more than 5, yeah? You say 6 or 7, because if one goes down, you're redundant, you're still fine. Does that make sense? So what I'm saying is, this is the way you do calculation of how many servers do you need if you want to scale the servers, what that looks like, yeah? Queues wise also the same thing. You have like, first in, first out. So one thing you have to make sure is that if you are doing first in, first out, how many transactions per second are coming in? 3,000 per second. You cannot do more than 3,000. That's not possible from system perspective. So in that case, so that's where you're using FIFO. Or if you're not using FIFO, then you're using another way to connect. You're using regular, storage, which is 20K requests per second, can also be processed in that case. No. How do we calculate all these response time? That's an important thing. In that case, you can use Little's law. So what Little's law, if you go to barber, or if you're going in for a restaurant, there is a wait time, yes? There is a wait time. They tell you what the wait time is. How do they calculate the wait time? Little's law. They use the Little's law to calculate the wait time. So what you do is, there is a queue which is getting created, and there are consumers who are pulling from the queue and processing the queue, yeah? Think about like, you're going to a restaurant and you have to process so many people are coming in. Now what's happening is, the Little's law says W is equal to L, which is work in progress, how much work is coming, and how much can I process, which is my workers who are processing the records, yeah? Which is the throughput. Using this calculation, now if I do that, if there are 10 requests which are coming in, if there are 3 workers doing per second, 10 processing, then my request is 1/3 seconds. Now, the problem which comes in is, let's say, you have a Diwali festival, or you have a Black Friday going on. In Black Friday, work in progress increases. Now you have more load coming in. Because more load is coming in, you need to add more workers, yeah, to really support that. In order to do that, I added 5. Now my response time became what? 1 second. Now think about this. Why I'm talking about all these things? Because these are all the calculations you need to do in order to make sure you're designed well. So what happens is, estimate how many servers we need to serve, to read the request, considering each server is a capacity of handling 7 requests per second. And 46 million requests per day needs to be calculated. So I'm not going to ask you to do the math. I'll do the math for you. And then we found out, it's a simple math, like 600 requests per day per server you are trying to do here, yeah? So you come to know how many servers do you need, which is 90 servers do you need in this case. Similarly, 46 servers and 46 million requests. How much per second you can process? You can do the math. In this case, saying 10 requests per second, yeah? So why I'm talking about all these things is, once you know how many requests are there and who all are calling me, which is called as a context diagram. So you need to create a context diagram where the productive system is there, a user is logging into the system, and now they're trying to process, and these are all the methods they're calling. They're calling get the product details, add to the cart, do the fraud management for them. Once you build that context diagram, for example, restaurant system will have get me more of the supplies from the system. So once you build that context diagram, now you know for each of the methods how much data you need to process, yeah? So that's the reason we are trying to do this thing. Once you know the information flow of that context diagram, the next thing which we need to look at is what database to pick, yeah? That's the next question to answer. So that's where, what I suggest is let's go to the dbengines.com. So if you go to DB Engines, so database engine, dbengines.com, and then if you go into these engines, so then here you can actually find out all the ranking of all the databases. So what's really happening is key values. This is what I was talking about before, okay? Redis, everybody thinks Redis is just a key value store. Not really. It does document store, graph storage, spatial database, search, and time series. So if you want to know more about it, tomorrow I have just a session on this NoSQL, NewSQL, and SQL database. Just 1 hour I'll spend all on this one itself. But what I'm trying to say is that everything is converging. Everything is what? Converging. All the databases are supporting all these information. It's not just one database which is supporting it. Earlier, it was only document DB. So if I go to document DB here, MongoDB is a document database. But it also now started supporting spatial databases. Spatial database is now a newer type of database which is coming in. So you can now send an email, hey, you are near my store, get my product. That's what's happening in this case. Or it also supporting like MongoDB in this case. Yeah. Another one is key value storage. Key value storage, I think we talked about this. 1 second. Wide columnar storage. Wide columnar storage is Cassandra database is the number one in this case. So Cassandra database is also storing a partition. So what's really happening is because we have petabytes of data is there. If you have petabytes of data, where are you going to store it? In a partition, which is a chunk size partition. It does not need to be very small partition. Once you store it in that, it becomes much easier to retrieve that data. So here is my question to you. Can I store in Cassandra database JSON blob? Can I store? Yes, you can store that, yeah? Now, Cassandra database can also function something like a MongoDB in terms of once you get the partition, now you're functioning on top of it. So it's like, it has become like an easier way of, kind of working when we are working with these databases, okay? Now, this is what the trend is going on. Graph database is really picking up. See this here? So I'll talk about more on the graph database later on, but think about any connections you want to make. Neo4j, I think there is a stall here for Neo4j, yeah? So they are the number one in graph databases and using that database. Now, why I'm talking about all these things is if your product owner says that, hey, request rate is very high and latency is very low, you have to use a cache. Or you have to use Keyspace, Amazon Keyspace, or Cassandra database, or Dynamo database to really store that data. Yeah, so it becomes very, very fast. Some people are saying we need to have a very high response time. How do you do that? By just picking between these two things. And of course, you need to worry about the security aspect also when you are building it, because there could be a SQL injection attack and other attacks can be going on here. So now let's take a look at Uber. So Uber used to be like, combined application. It used to be one PostgreSQL database was there, monolithic application was there. What they did was they converted this monolithic application into supply and demand. Supply don't know about demand database. It's all event-driven approach they are trying to do here. When they did that, they first did the empathy map. So when they did the empathy map in which they find out eco walker. Eco walker is the person who walks every day in a happy life, and then in the weekends he wants to party out. Friday night, Saturday night, they want to go and party. And in the party, after the party is over in the club, he want to go back and do another party. So how do they support it using Uber? They're looking at different scenarios. Once you understand their scenarios, like, this is another example for Boltonic, who want to get this scenario. Same thing with the commuter and other things. So I don't have any problem with these. Like, you can have multiple of these scenarios, but these are becoming use cases now. Yeah, we are all familiar with story. We all write the stories, yes? System design, one thing I always say is, in a story, we sometimes miss out on precondition and post-condition. We miss out on that because we always write story. Yes, as a user, I want to do this to do these things. So if you start analyzing those, hey, what is my precondition for this use case, is very useful. Okay. Second thing is, main course is the story. Like, hey, how I got the ride. But the alternate course is, what happened if the closest driver did not accept the ride? Why? The person who is asking has a bad rating. They did not accept the ride. Same thing is with the exception. How do you do the exception handling? That's a big thing. Like, if the ride stopped in the middle, car stopped in the middle, what do I do? How do you tackle with those things? Now, this is the golden nugget. I call this as a golden nugget. You create web services for this and really support them. So you find out from functional requirement, what is the ETA? What's the estimated time of arrival? What's the price? What's the location? And what could go wrong in this? That's what you're trying to find out. Once you find out what can go wrong, for example, you can find out, hey, this person is not able to reach the destination because access point, they're missing out the access point. So what we add the access point to this as a service, and then we'll be able to support that. Now we find out what is my availability, 99.99% available. And in order to do 99.99% available, what if one data center go down? What do you do? What do I do? Huh? Create what? Data center, another one. But the flight is going on, the car is going on, they're going from one place to another place. Like, the whole thing blew up. The data is not like, it would not be there, low latency and then high consistency you need to do. In some cases, you don't need data center. So what Uber decided, or they decided is, hey, because the data is also there in the mobile device of a passenger and the car, how about we keep all the data? If the data center is not reachable for us, how about I do one thing? I can just directly call them. That is an easy solution for us. So that's what they are doing to create the high availability for them for 100 million active users. Same thing is true, which is happening in the operational cost is low. In order to do it, they added text messaging, they added reminder, they added calling the driver and rating of the passenger. Yeah. Another thing is response time should be less than 500 millisecond response time. So that is, how do they achieve that? So demand and supply, they meet the demand and supply. So what they're doing is, whenever all the people are coming to San Francisco, when they're coming to San Francisco, that means demand is coming to San Francisco. So where does the driver need to be? Near San Francisco, yeah? In the night, they're all coming back. So they are actually enticing the drivers to be near those locations so that they can do the capacity planning using that. So that's what they do with the monthly active users, and the 100 million active users are using the system. So what that means, 10 million booking, what that means, if your 2 megabyte of data only is there, that means 20 terabyte of data you need to process. How much? 20 terabyte data you need to process. So this is something which I'm showing. Why I'm showing this? Because this is important for you to understand. Because every company has a business canvas. You need to know what are your key drivers, who all are using your systems, and what is your value proposition. Your company will also have it. And this is something good to know, because then you can actually help the company implement the solution. So what's really happening is, now I'm logging into the system. From the user is logging into the system. And using the Route 53, they know I'm in India. So if I ask for something, I'm going to go through the CloudFront distribution, which is near my place, yes? And that's what I did. I got the static content from here, and I am getting the dynamic content from here. Can I cache the price values? Can I cache the pricing, which is dynamic? Yeah, for 10 minutes, 15 minutes, I can catch the pricing. So even if the pricing can fluctuate, within 10 minutes, you keep the same price. So that is one way of like making sure that you're not always calculating the price when you're trying to build the solution. And then you're going to availability zone and sending and calling the auto scaling and on the server on the other side. Now in this case, the important thing is whenever a user is calling in, you are going through a WAF. Web Application Firewall. So what is a Web Application Firewall doing? Any company, it needs to go through that because any request which is coming in, if there is a SQL injection attack going on, let's say there is a SQL injection attack, you need to be able to find out before it hits you. So that's the important thing for you to know. If you're allowing a guest checkout, let's say there is a guest checkout going on, in the guest checkout going on, also you can also get a SQL injection attack or some attack can going on at that time. You need Web Application Firewall to protect yourself. Can you block the traffic? How can you block the traffic? Anyone? How can you block the traffic using Web Application Firewall? Huh? Yeah, you can block the traffic for the IP address, yeah? Or a machine which you can block the traffic at the CDN level. You can block the traffic at here. You can also block the traffic at the NACL level, network access layer. That's another place you can block the traffic, allow and block the traffic you can do in this case. So what's really happening is when the demand is asking, hey, I need a ride, is going to the Web Application Firewall through the load balancer. Now it's going to the discovery service, DISCO, which is going into different regions, and I'll talk about that in a second how that works, but it also is sending to the Kafka stream. When it's sending to the Kafka stream, see here, you are able to do the price search. You can able to see how many people are riding at any given time. And it's using Kafka to do the log analysis also. So what's really happening is how do you send the notification? So this is what happens. Some people ask me a question on this one, that's why I'm showing you this. A user is saying payments. So I have an API gateway, I'm calling a payments method. A Lambda function is called for the payment method. Now I send a payments method, I send it here. But now depending upon the subscriber who's calling it, I'm sending it to the right database for that one. That means depending upon the tenant, where it's calling me from, I'm sending it to that particular subscriber to that particular event. So that's what we do to really support this model. For example, the perspective is I can send the message out to SNS topic. Now it is sending it to a queue to process that particular topic. So what could happen is if I have a publisher and the topic is saying green, topic is saying blue, depending upon the green service, I'm calling queues. A blue service, I'm calling some other service. That means there is an error message, you're calling a different topic. Yeah? So that's another thing which you can do when you're building the system. Now this is a powerful technique which I have used in my project, which is called attribute-based filtering. So what you do is, you're sending all the messages to the SNS. Depending upon the attribute you're sending, whether it's an error message or whether it's a tenant ID which you're trying to process, you send it to that particular queue and then they will be processing that record. Yeah? So that's what you do, and then send across. So for example, order is being placed, order has been cancelled. So that means you can do compensation pattern also using the same queue. That's the advantage in this model. So you are able to do compensation pattern also using this particular queue. So what that means, if you're using an event bridge, which is like same thing as pub/sub model, you are sending the data to the event bridge, which is a JSON object, and depending upon the sales or the email type of data which is coming in, you're routing the traffic to different locations. Okay? So that is another thing which you can do in this case. Now, when I'm doing a ride, one thing to keep in mind is, when I'm doing a ride here, I have this service which is calling the topic for me. This topic is now calling a queue. So what is this doing is doing a retry mechanism if this service is down, and this queue is added to flatten the peak load. Yeah? What that means is you are only designing for what? Average load. See, remember I talked about it, 50,000 requests per second, you're designing for that. 5x, you're also designing for 500,000 just by adding a queue here. So queue is acting as what? Buffered load balancer. So what is this? This is acting as a buffered load balancer for solving your problem. So similarly, you can also call the Kafka queue with multiple consumers consuming that same data. Yeah? So that's the advantage of using this. So let's take a look at different services you can create. You can create an incentive program. You can create a payment service. You can create a user profiling service. So these are the multiple services which are going to consume the same data and processing that. That's what you're doing. Oh, by the way, priority queue. Think about it. A driver who's sitting idle, okay? You don't want that driver to sit idle. Next time, around that same area, someone requests a request. Where should that go to? The driver who's sitting idle. The driver who's coming there, they already got the ride, they will get the previous seat. So you need to do priority queue and enqueue that data. So that is one thing you have to add to really support that kind of model. Single shortest path. So what really happening is that, you know, when you're trying to build this, let me show you, I think it should work. So let me show that in action. So what I'm trying to do is, I'm a service company. Anybody here is a service company? Or you are actually servicing electricity or like appliances, you're trying to serve a particular appliance which you're trying to build. If you're building a particular appliance, what you're trying to do, you're starting in the morning and go till the night. And you want to make sure that, hey, I'm able to go through all the places which are nearby. I start in the morning, give me all the routes for what you have got, and I should be able to start in the morning and come till night. So what this service can do is, I can set my goals. Tomorrow morning I start at 6. 5 minutes it takes, let me make it 15 minutes to service something. Now I want to plan my route. What it will do, it will automatically plan the route for you, going through different locations, and then it will give you a result. Now this one actually gave you a result of one route, starting from here and finishing up all your routes going from one place to another place. Make sense? So this is actual service you can create as a service-based industry when you're building your solution, which is based on Google Maps and other data. Now, another thing which comes in is how to get latest customer from the Uber order. So when you are going to have, like, you know, order services there, you're processing that service. Now you have another service which is the customer services there. Now what do you think I should do? I can combine, get the customer first and get the most recent orders next. Yes, I can do that. And actually somebody asked me the similar kind of question they asked me on that end, but is this efficient? What do you think? What do you think we should do to make it efficient? One API, yeah, this is one API call to call this and call this. Yeah, you can do that. Huh? Get the order first and then the customer. But the problem with this is not going to be scalable. You know, that's where the problem is. So you use the CQRS model, command query request segregation. Now what you do is you publish it to a bus, which is event-driven model. Now you create another data column which now will be much faster. 250 millisecond response time. That should be our focus when we are trying to build this. Now this order view will be 100 millisecond response time. So that's the advantage of, you know, finding the latest model like this. So what's really happening is, I was talking about this. So another thing what you can do is, see this here. When any rider is asking for the request, hey, I want this request. My driver is here. They're calling the geospatial coordinate. A driver is there in some index, some index in Cassandra, they're there. So they're storing in a cache, in Redis cache, they're storing D1 colon H1. Why they're storing D1 colon H1? Because Cassandra cluster, one Cassandra cluster is not enough to support all the driver in all the location. Yes, you agree? In that case, if you do this technique, you can follow in your projects also, where now you are having a cache, where do I need to route my traffic to? This is called at routing the traffic while in motion, where you are doing sharding of the traffic while in motion. So this is what the technique which a lot of companies are using. Now they are actually calling the geospatial coordinates. If somebody asks for a ride, they find out nearby geospatial coordinates and be able to do that. Let me talk about this for a second. So what's really happening is, this is the US map. So if I'm looking at a particular area, this cell, if I'm located here, see this, I'm located here. Now what's happening is, I have all these cars nearby. I'm going to do a route to all these cars, and these cars, let's say this segment is there. This segment is storing This segment is storing 20 cars. 20 drivers are there. And this segment is storing 20 drivers. This segment is storing 20 drivers. Now what happens is that it's a downtown area where there are multiple segments are there. You can break that segment. So that means if it becomes a bigger model, like you're trying to say 20 cars or 30 cars are there. Let's say there are 100 cars are there around that area because a lot of people are there. You can break that also into smaller segments, cell. Now you know which cells are nearby me and then call them. That's exactly what they do, and then they get that request. And then whenever any trip request is coming in, they're putting in MySQL database. People say don't use SQL database. I disagree on that. That's stupidness. If somebody is saying that, like, that means your transactions are not good. Yeah? You need to put in a transaction. But after some time, after the write take place, after let's say 7 days or something, remove it and put it in Cassandra. No problem. You see what I'm saying? So any transaction, any payment you want to do, you want to put it in that. Make sense? So that's one thing which is important. Another thing they added was these access points. Google Map did not give the access points. They added these access points, and now they're able to process. Another thing they added was, see this, another thing they added was, right from here, think about this is Bangalore. Google is giving this map. Okay, go here and then go here and go here. The driver is smart. Okay, what they say, okay, this is shortcut. And there are a lot of shortcuts I know in Bangalore. A lot of different gullies, you can go from a lot of different places. Now they use one time, they use second time, they capture that as a recommendation which is coming from Uber now. Uber now started learning from a machine learning perspective and started using that. So that is one thing you have to look at the data, how they're using it. Are they following Google Maps or not? And that's exactly what they did. And then they use the Map Cruncher 2.0 to do the segmentation and be able to support this model. Yeah? They're able to support this model and use it. Now the problem which comes is like, hey, you have this building. See this building here. This building is there. Somebody asked me a question. I need to do very, very fast processing. Very, very fast processing. Like, financial processing I need to do. You got to use a tool which can do it, that kind of thing. So Uber, what is it doing is, it's calculating from here the distance between the node of the person and all the other access points, and finding out the shortest path in less than 20 milliseconds or 50 milliseconds. And representing to me, hey, do you want to be picked from here? When they say, I want to be picked from here, then the driver is coming and picking up from here. So how do I do processing so fast here? Using Spark. So we can use Spark to really do this processing very, very fast. Okay, so I'm going to jump on to the last one I'm going to discuss. I think we got like 20 minutes, so we should be 15 minutes, we'll be able to cover this one. Now, if you understand this model, if anybody here is B2B, B2B2C, if you want to understand that model, if you want to understand how Amazon works, how Flipkart works, how eBay works, how B2B works, this is good for you to understand that. And you can say Airbnb, how they work. Any of the hotel reservation or flight reservation, how they work. If you understand, then you will be able to solve that particular problem. Okay, so what's really happening as an architect, you have been given a registration form, you will be able to register, you should be able to order the data, you should be able to support the feedback from the customer and do the search, filtering mechanism. That search is important, like you should be able to search very, very fast. That's very, very important in this case. And then you should be able to do non-functional requirement by security, scalability, usability, and then integration with the third parties, because it's not just one party which we will be working with. And GDPR compliance also is there in that one. So what's happening is, as a functional requirement, what are we doing? As a seller, I should be able to sell the product. So why that is important is, that means you will have people, if you are creating a marketplace, anybody here creating a marketplace for your product? You have multiple customers, yeah? Which one is this? Sellers are putting product in your marketplace. So you're using the similar model like this, yeah? And then the buyers can buy it from there. So the non-functional requirement for that, thank you so much, thank you very much, yeah. So in that case, non-functional requirement, 99.95%. That means how to achieve in distributed system. That's a tough part. It's not that easy to do it. The questions are what type of system we are trying to do. What type of order management system is there. So I'm not going to go through the questions, but you can read it on your own. But the perspective is that these are the questions we should ask. As a freebie, I'm just giving like what questions you need to ask when you're trying to build system like this. But the first thing which will happen is business to business. So what you're trying to do is you want to entice the customer. Seller is coming to your system. Amazon, somebody is going. You can create your own product line in Amazon right now. You can start selling it right away. So what's really happening is you attract the customers, you store the data, and you are storing and sell the products here. Now what's really happening is that you are running all these tools. Now, where are you going to store the seller data? Are you going to have one database with everything in it? Anyone? Huh?
Actually, we are using a third-party service for that.
Okay.
They are also keeping the data.
The problem, this is a problem, so you can have one database for the whole thing. But you have to decide, maybe you need a separate database for each of the product line which you are trying to create. Another is how to make it multi-tenant. It's very tough to do multi-tenant system. So that's another thing which is there. So back of the envelope calculation say that, number of weekly and monthly active users. Depending upon the average order volume which you're trying to get, you need to predict how many orders you're going to get. And what is your peak load? That is the peak load you're interested in. And you solve for that, then you're all set. So we're going to solve for the peak load also. Amount of data generated is important, how much data you are generating, how much availability uptime you need to have. So these are the questions you ask. So let's talk about Black Friday. Black Friday is there. Number of visitors is 1 million. Yeah, 1 million visitors are coming in. Now what's happening is, what is 10x of 1 million? 10 million, yeah? 10 million are coming in, and each page is 2 megabytes of pages there. And average page visits are 10. So somebody did 10 page visits they are doing. Conversion rate is only 5%. That means you're not going to get all the customers which you're getting here. Average order is $100. Based on this, now you can do the AOV calculation and then find out 10 million customers and 200 terabytes of data you are trying to produce. How do you produce that data? How much data you're generating. So the first thing you're going to do is you're going to connect. Store owner is going to first go in and connect through Amazon Cognito or Okta. You want to connect from there and make sure they're authorized. They sign up for the deal. And then going through the Amazon API gateway, and you have a Lambda function or a microservice to create a template for your service where you're adding an API, a Lambda function, customer, product, and order. So these are separate table for each store which you are trying to create. Can I have multiple stores? Why not? So you can have multiple stores also added for this. So when I'm working on Amazon service and I'm logging into Amazon, what's the first thing which happens? I get recommendations. Yeah? How did that recommendation came there? That's a service which is providing that service. Yeah? So what do you think that those things came from? Huh? From where? Browser history could be one thing, but see, this I'm talking about a big system, how they are doing it. They are getting the data from Kafka stream. Okay? They are pre-processing the data per user basis and have it ready to go a timeline. Similar to the Twitter timeline. We talked about it, yeah? Twitter keeping all the timeline together. Similarly, Amazon is keeping all the timeline together for the recommendation ready to go in a Cassandra cluster. So for a given customer ID, they have all the recommendation ready to go. That's why it's very fast. When you log in, you're going to see recommendation right away. How do you see that? So that's what you're pre-processing. This is where Spark is there and Cassandra is there. Someone asked the question, how do I do it faster? This is the way to make it faster. Now what's happening is that whenever a user is logging into the system, are we going to the database and getting their information? No. Cache all the data. That's why I'm having a caching of the data which is going on here. So that's where we have active users are cached in the data. Now whenever I'm doing a search of the data from the load balancer, I have a search service which is actually calling what? Elasticsearch, which is another database. So Elasticsearch is what? It's another database which is there. I'm calling that database. Why I'm calling Elasticsearch? Because Elasticsearch is the fastest search you can have. You know, you can use Elk Stack for that. You know, there are other Solar is there, etc. You can use that for that particular service. Now, where do they get the data from? From the Kafka stream, new product is added. When the new product is added, now this is where Kafka really helps out, because multiple consumers are consuming the data. This consumer is consuming, this consumer is consuming. So this consumed through the queue. Now this has been pulled, and then we are adding the data in the search. That's the advantage we get here. You know, another thing which we are doing is whenever somebody is buying some product for us, we are putting in the wish list and the cart list service. And the warehouse service is there, which is giving me how many products are available at any given time. Yep. Now think about a situation. Now what's happening is you can add on top of it location-based services. User-based services you can add. You can add the category-based services on top of it, yeah? As part of the deal. Now what really happening is when we are trying to create these services, now I have placed an order. Order is placed. What's the first thing which happens? I need to see my order history. Where should I keep my order history? Anyone? Where should I put it? Huh? Not in the archive. Huh? In the structured database, yeah. That's why I have MySQL there. See this here? And are you going to put it in MySQL only? No, you're going to put it in a cache also. Because that's what happens, like, you know, you want to make it faster, but only for 10% of the use, like for the most who are using the system a lot. Only for those users, you're going to cache the data and have it available. But now you're going to cache the data also and also put it in the database, which is archived database. That's one thing which you do. Another thing what happens is whenever an order is being placed, now you have to maintain what? States. Yeah? State management you need to do here. So whenever an order is placed, thank you for your order 202. Now what's the first thing Amazon does after that? What do they do? Acknowledgement, yeah. Then second thing is, thank you for your order. Third thing is they charge the money, dollars. You know, they charge you the money right away. Do they go to the warehouse and find out that the product is there or not? No, they don't do that. So that is what you need to do in terms of using this service through the Kafka stream. Now it is going into the warehouse. Oh, now we found out there is a problem. What do we do if there is a problem? I don't have the product. What do I do? Huh? Cancel and revert the money. That's where reconciliation service comes in. So you're reconciling it and then be able to provide that service, yeah? So that's what you're doing and creating the distributed system. And disaster can take place anytime, you know. When the disaster takes place or something happens, late delivery, either you're doing a late delivery or you're informing the user and refunding it. That's what you're trying to do when you're building this solution. So that's what happens when we build this solution as a whole. Now, same thing. Now, why I'm talking about this, I want to do a revision. I like revisions, yeah? So you're going to see online airlines booking system. Okay, you are an architect, you want to do the flight booking. Flight booking needs to be done, all the flight needs to be booked, and then view all the orders and the pricing of that, 24/7 availability. Solve this with me in 5 minutes and you will be pro at it. Okay, what are we doing here? B2B. Who needs to be the B2B here? Airlines. Yeah, airlines are B2B. So airlines will need to put the data in there. And then what are we doing? Booking system with recommendation system. Hey, go from one place to another place. And you have a booking system. And then you're consuming that data, going from one place to another place. This is what the flight looks like. Now, if you see the diagram looks like exactly the same. Now we are solving the same thing using the MyCard with all the logistics service going from one place to another place using this model. You're asking the same kind of questions. Is it domestic flight, international flight? What the payment gateway you're using, multi-language you need to support or not, things like that. And then you're trying to find out all the airlines where they're storing the data. Asynchronously calling the airlines and be able to support that. Now the airline which is storing the data in Cassandra will win. Yes? Airline which is storing the data in MySQL will not win. In that case, airline need to store the data in Cassandra. That means they will overbook. If they overbook, you need to do what? Compensation pattern. So that's what you do really to build this system as a whole. In order to send the data from SQL to the Cassandra database, you use Spark streaming to send the data using Kafka. So that's something you can add. Now you have done the booking. And same thing is true with the Airbnb. If you think about Airbnb, they are also the same thing. They disrupted the whole market. But it's the same kind of questions and same kind of model is there where you're doing B2B in this case. You're putting in the products. Maybe in this case you have one database. It's fine. But your tenant-aware database is there when you're working with this. Yeah. So you can look at this data. This remains the same. This remains the same. This remains the same. So that's pretty much. I think we have few minutes. So if you have any questions, you can ask me. But I wanted to just cover this much for now. I know that it's been a long day for everybody here. But first of all, thank you so much for joining in. What did we do in today's session? What we did was we started with the design. We looked at the design aspect. And what I gave you is a clear definition of how do we attack functional requirement, non-functional requirement. How do we do back of the envelope data calculation? That's very important. Once you know what you're doing, and then we looked at 3 or 4 companies which are doing the similar thing. So thank you guys for all joining in here, and I hope to see you in another session. Thank you.